Awesome. Thank you, Ernest, for the introduction. It's awesome to be here. This is actually my first talk, as Ernest mentioned earlier. So if anyone's got any feedback, it would be greatly appreciated after the talk. Cool. So my talk is on ergonomic error handling with Rust. So an outline of where we're going today. So first we'll talk about like an overview of error handling in Rust and how that language, its approach to it. Then we'll talk about making error handling ergonomic, which is just like the bulk of this talk, and how Rust tries to make it just easy and enjoyable to use. Then we'll just talk about making errors informative and the future of error reporting. So cool. So a bit about me. I'm a software engineer at Aerobotics. We're a startup building agri-tech technology. And so we basically build tools to help farmers practice farming better. I'm based in Cape Town, South Africa, and my work sits at the intersection of software engineering, machine learning, and computer vision. And the team I work for is responsible for building the backend systems that run our computer vision and machine learning solutions. I've been writing Rust for roughly 6 months, like in my free time, and just learning about it, just really enjoying it and the community, hence this talk. I write a little bit at senyosimpson.com and write a whole lot of annoying tweets at Senyo if you want to give me a follow at any point. This is just a picture of Cape Town. I thought I'd show you London. It's just how sunny and amazing it is outside. This is actually from a place called Sunset Rock. It's one of the best places to see a sunset. And yes, it really does look like this. Cool. So getting into it. Why is error handling important? So the main theme of this talk, and the one thing I want to thread through, is that error handling is really just about communication. It's about communicating to developers what's gone wrong, where it's gone wrong, why it's gone wrong, and just providing the information so that we can debug and move quickly and really just understand, how our programs work and the error cases that arise. So yeah, just looking at it, error handling obviously prevents undefined behavior. So we don't want our programs to continue executing, if we've got invalid state of some variables. Obviously that can lead to things like exploits and obviously a bad customer experience, and just making lives difficult to debug when we encounter those errors. Provides context to failure modes. So that's just understanding, what's happened, where it's happened, and just understanding like the surface area of failures in our programs. And again, just making it easier to use our programs. And then, of course, it makes developers happy. Not writing errors, but using libraries and tools that have good errors is always enjoyable. And who doesn't want happy developers? So how Rust does error handling? So as many of you know, Rust doesn't have exceptions, and instead errors are returned. So this is similar to a language like Golang, where we just return errors instead of having exceptions. But differently from languages like Golang, it takes inspiration from the ML family of languages and adopts the result type for handling recoverable errors, which we'll talk about in the next slide. And then irrecoverable errors are signaled using the panic macro, which we'll also touch on. So recoverable errors are obviously errors that we know how to handle and can take like an alternative path if we encounter them, and then continue execution as normal. And those are like the bulk of errors that you'll probably face, so we know how to just deal with them and either report to them or pass them to the caller in this case. So recoverable errors are communicated basically using this result type, which is an enum, which has an OK variant and an error variant. The OK variant is let's say, selected when the computation is successful, and then the error variant, obviously, when there's the error. This is quite nice, obviously, because it embeds the idea of a fallible computation in the type system, but also it means that we have to unwrap the result to get the value, or in this case, the error. So let's say we have a result that has a string or an IO error. If we need to use that value, we have to unwrap it to get the value inside. So if it's successful, we get the string. If there's an error, then we have to handle the error. And this is nice because it prompts us to obviously handle our errors and just enforces that through the type system. So just a case of using a result. So in this case, we're creating a file called ferris.txt, and this returns a result with the file inside, obviously an error in the case of errors. And then we can unwrap using match on the enum variance. So if it's okay, then we just assign the file. Otherwise, in case there's an error, then in this case, we've chosen to panic. But we could have like more complex error handling logic there. And then similarly below here where we can write or we write into the file. And if it's okay, we do nothing, otherwise we panic. So one thing that the result allows us to do really is to bubble errors. So oftentimes we don't want to handle the error where it's encountered, and instead would rather propagate that error to the caller. So that makes a lot of sense because the caller often has more information and like a better field of view or perception of the problem. And again, if you just think about it, like they operate in different contexts. So the same error can arise in different contexts, and you'll probably want to handle it differently depending on that context. And so you want to give the caller the power to handle those errors. And so the caller then implements logic to handle the error as required. So an example of this, of bubbling errors, so we have a function init, which just basically wraps that other code that we had before with writing and creating file. And we return a result that either has a unit type or an error. And in this case, the bubbling happens like, so when we want to match on the file, we either assign the file variable if it's okay. If there's an error, then we do an early return of that error. And so that happens when you create the file and write the file. And then in this bottom section here, we have like a piece of executable code. And you can see like the caller of the function then can implement some logic. So in this case, if it's okay, we do nothing. And if there's an error, then we panic and just say could not initialize. Obviously, that's very rudimentary. And most of the time would probably have some smarter logic around how to handle that. But for an example, it's good enough. Cool. So irrecoverable errors. Irrecoverable errors are obviously errors we just do not know how to handle. They're often the case when there's bugs in the code, and the best option is to just panic and crash. So a panic basically crashes the program and stops execution immediately. You can kind of think about it like an exception. If it's not handled, an exception is not handled, it crashes. Obviously, in a panic, in theory, we can't handle a panic, and so the program will just stop immediately at that point. So we've seen this before, like all of the code examples happened before, had a panic in them. So, but just to go over it again, in this case, we're writing hey Ferris to a file. If it's okay, do nothing. And then in this case, if this branch executes, then we panic, and this will just crash the program and then it'll end. So yeah, that's basically like a small tour of error handling in Rust and just like the real basics of it. Cool, so making it ergonomic. So Rust really emphasizes language ergonomics. It's one of the first things I kind of picked up about the language and or like the community around the language, that they really care about making it as easy to write and just really developer friendly. And that's really great to see, especially in the face of all the complexity that Rust does have. I think that there's a great push to just making it an enjoyable experience to write. And so in relation to error handling, like Rust has several convenience methods or syntax to reduce error handling boilerplate. So as we saw before, bubbling errors requires boilerplate due to the matching syntax. So you can imagine that if every single time we wanted to bubble errors, we had to have that match arm where we have like, if it succeeds, then we assign the variable. Otherwise, if it fails, then we return the error. It's a lot of boilerplate. It's kind of like in Golang, where they'll always complain about how they have to, the most common line they write is if error does not equal null, and then continue their code. So and because it's such a structured thing, we can actually take care of it through syntax or functions. So in this case, like Rust introduced the question mark operator, just known as try. And it's a solution to reducing the amount of boilerplate. So it replaced the try macro that was previously in the language. So a case of this is like in the non-try method. As we've seen before, we have an OK variant, and then if there's an error, return the error. But using the try operator method or question mark operator, we can just append a question mark at the end, and then this is functionally the same as this non-try method. So if it succeeds, then the file will be assigned, and if it fails, then it'll do an early return. And as you can see, it's a simple quality of life improvement, but it really, really just makes the code a bit easier to read, a lot less verbose, and just much more easier to write. And so you can see that there really is a commitment from Rust language designers to just making the language as ergonomic and enjoyable to use as possible. Cool. So the same kind of a principle can be applied to panic. So in the same way that we have that matching syntax to return an error, sometimes you just want to panic on error. And so there's this unwrap method or function that we can use, and that's kind of like how we can achieve the same functionality. And so if there's an error, it will panic automatically. So here we can see one thing to notice is that we don't need a return type anymore, because if it fails, we just the program crashes in this case. And so you can see here we use unwrap to panic if it fails. Otherwise, execution continues as per usual. One tip here, or one commonly known thing, is that we shouldn't use unwrap so much in production. One reason for that is obviously, I mean, you don't want your programs to be crashing all the time when you could just implement error handling logic. But it is commonly used when you're prototyping, or at least when you have a guarantee that this function wouldn't error, and so you don't need to actually implement error handling logic. Cool. And in the case where it does error, we can get this kind of like error message. So in this case, you see we panicked, and the message says that permission was denied. So we obviously didn't have permissions to write to that location. Cool. And there's actually many more methods that I won't discuss, but they're worth just going through in the language. So we've got things like expect, which is like panic, but you can set an error message, map error, unwrap or else, unwrap default or default, and many, many more. And all of these functions and syntax methods allow us to really just write error handling logic in the most ergonomic way possible. Again, just improving the developer experience of writing Rust. Awesome. And so, as I said at the beginning of the talk, like one of the most important things is that error handling is about communication. And so one thing we want to say or do is write really informative errors. And so good errors are highly informative. And they just, the idea there is to just really give a full picture of what's going on when we encounter a failure case. So a developer understands, what went wrong, where it went wrong, how, and just provides a lot of context into that scenario. Obviously, again, improves developer experience and helps debug issues much faster. And of course, makes developers really, really happy. So an example of a really great error message is the C++ error over here. I mean, there's just so much information here, I can barely understand it. But jokes aside, I just typed in like the worst C++ error I could find and put it here. But yeah, I mean, I must admit that I think that C++ developers are wizards for being able to understand this. To me, it's crazy. It really is. It really is crazy. Okay, but moving on. So one thing we have to ask when we're thinking about what an informative error really means is whether we're writing an application or a library. This is just because what informative means is different depending on whether it's either an application or a library. And so for a library, the most important thing is that we create meaningful custom error types. So a library obviously has a domain and a context, and we want to be able to capture the surface area of errors for that library. And so we want meaningful custom error types that really capture that for us. As well, they must wrap standard errors where necessary. So you can imagine like if we have two libraries, A and B, and they both output IO errors from the standard library, we still want to be able to understand which library they came from. And so we want to wrap them so that those errors go under like the library's namespace. This allows application to differentiate between various errors. And yeah, custom errors should always implement the error trait from the standard library. This is just for compatibility reasons. So I read that like before my time, there was a crate that was quite popular called Failure, and it had its own error trait, I think, called Fail. And the biggest issue there was just compatibility across the like ecosystem, or when you're writing code across your whole code base, because you had to mix and match these two traits which didn't interplay too well with each other. So custom errors should always implement the error trait from standard library. And ideally, they should never panic. Obviously, well, not obviously, but most of the time, you don't expect a library call to crash your application. Cool. So applications are different in the sense that they consume errors. And so they make informed decisions on how to handle those errors, and then provide context as to what happened when those errors occurred. And so that's their role. And yeah, applications can panic, obviously at the application level, if there's no option, or you've reached a terminal state, the only thing you can do is to panic. And they're responsible for deciding how errors are formatted and displayed to users. So a library must just encapsulate all of its errors in these meaningful custom error types, but an application determines how that's displayed and communicated to the user. So for a application, adding context is extremely important. Again, just going back to error handling is really just about communication. So errors need to include the context in which they were generated. Again, provides developers clarity on the error case and improves our ability to discover and diagnose it. So just walking through what I mean by like context or informative errors. So in this first case, we have an uninformative error where we at least know that it's an IO error. Obviously, we can't find some file or directory, but we don't really have much information outside of that. We don't know like where it came from, what line of code was there. We don't even know which file it was. And so, like at least we have some information, but really not enough to make our lives easy. So we can improve this by having something like in a message saying which file we couldn't read. And in this case, again, it's just very start text, and that provides us a bit more information. Additionally, we can add some more information. In this case, we've added a stack backtrace. And so that just provides the developer with more information about the error that happened. And there's some other quality of life things that we can do, sort of like adding the location where the error occurred. And then again, just providing them and making it easy for them to debug. Libraries are just, the most important thing again is creating custom error types. So in this case, I'm using this error, which is probably the most popular library for creating custom error types. It just does a lot of the heavy lifting for creating custom error types using the standard error trait. And in this case, we're trying to make beats, of course. And some errors that we have are like there's invalid notes or an invalid format or an invalid instrument name. And then this last one was quite nice, is that we've wrapped standard IO errors through our own type. And so any IO errors from that are raised or that are, sorry, not raised, but bubbled back through a function that has a beatmaker error will be namespaced under this beatmaker IO error. Cool. So just like it's some trivial use cases here. So in this case, you have some function called raise, which just returns an error. And yeah, we've just got this main function which matches on that. And if it's fine, it's all good. Otherwise, I was too lazy to write a good error message, but here's the error that was generated. And what's nice in the second example is that here we've got a file that's been opened. So we know that this is an IO error from standard library. But we still have a beatmaker error as our error type. And so what will happen is that it'll just be transformed into or mapped into a beatmaker error implicitly, and then we can just implement some logic again. I was too lazy to write good errors. So yeah, cool. So towards a better future. So error reporting can still be better. Yeah, I think like for most applications, we can still write better error reports. Two things. So one is we can make nicer to read error reports and provide suggestions to resolve those errors. So I think like best in class here is the Rust compiler. I mean, all of us have just known how helpful and informative it really is. You know, if you take too many borrows or something like that, it really tries to just point you towards what's wrong and even give you suggestions on how to improve or fix your code. So that's kind of like the feature that we're thinking of across all errors. And Jane Lisby, who's heading up the error handling project group, has a library called Air, and it's an experimental library that she's kind of used as a test bed for pushing the boundary on error reporting. And so just looking at some stuff there, what's quite nice here is, so this is an error report from that library. And what we've got here is an error, and then we've got like the order of errors that happen. So in this case, we're unable to read some configuration, and then the command exited. We've got the location, so where it happened in the code base, and then we've also got the standard error output, so no such file or direction. Additionally, we have this backtrace, and then nice quality of life improvement here, where we've got the suggestion, which is try using a file that exists. Next time, nice one, Jane. And you can see it's like really nice and easy to read, and it's a really informative error report. And then I was just thinking about, you know, like what happens if we had to have a chain of errors. And so she's also done some work there. And what's nice here is we've got this first error, which is like we've encountered multiple errors, where it happened in the code base, which again is something I mentioned earlier that would be like a nice quality of life improvement for our error reports. And then we've got the chain of errors. And so this is quite nice because you can trace back and see, you know, what chain of errors led to this current error that I'm facing now. And again, makes it easier to debug and yeah, fix your code or handle those situations. We've also got the backtrace. In this case, there's no suggestion, but I mean, it could easily be added. Cool. So that's the end of my talk. Hope you enjoyed that. Awesome. I think we'll change over, so it'll just take a bit of time to do so. But yeah, thank you for listening.
Absolutely. Yes. Thank you very much, Senyo.